Welcome to the IGC webinar on the basin evaluation of the Black Mesa. I am Eileen LeMay with Integrated Geophysics in Houston, Texas. It may be hard to believe that there is a patch of land that does not have seismic or well control, but there are indeed frontier areas worldwide. Before we start, a word about IGC. We are an interpretation house. Our forte is integration and interpretation of multi-sciences, specifically gravity, magnetics, seismic, and well control. In a nutshell, we analyze and display geological and geophysical data to facilitate an evaluation of an area for oil, gas, and mineral exploration. We have gained a trust of clients to give them an interpretation they can put to work. There is an economic gain in doing a basin evaluation using geophysics. The integration of gravity and magnetic with other available data provides an approach to evaluate the history of a basin. This leads to evaluating a basin's hydrocarbon productivity and prospectivity. Located in the Four Corners region, where Utah, Colorado, New Mexico, and Arizona meet, are the prolific Paradox and San Juan basins and the Black Mesa Basin. The Black Mesa and the San Juan are defined by three north-south trending uplifts. Starting from the west here, you'll see the Kaibab uplift. In the center, the Defiance uplift. East side, the Nacimiento uplift. Let's talk about two types of potential Paleozoic plays under investigation. Both are related to basement structures or faults. The first slide here shows the Tenneco Navajo 8351 well in the Capitan anticline area. These are sedimentary anticlines, or noses with controlling and sealing faults extending from the basement up through the lower section. A second play is stratigraphic structural. The example in this slide shows the Sinclair Navajo well in the Cow Springs anticline area. Note the sandstone pinch-outs or porosity grading related to paleo structures or carbonate fracturing resulting from formation folding or faulting. The stratigraphy of all three basins is similar with unique features. In the Paradox Basin, the primary source of rocks and reservoirs are the Carboniferous. In contrast, the San Juan Basin is highly productive out of the Paleogene. You'll see here that both basins exhibit potential deeper reservoir rock in the Carboniferous, though the source is still debatable. In this next slide, you see that due to surface erosion, the Black Mesa misses most of the Cretaceous section, limiting production there. The dolomitic shales found as source rocks in the Paradox Formation are not present in Black Mesa. The only alternative source is the Prada Resort Chuar Group, as seen in Grand Canyon. It has source potential. If the Chuar Group is found in the Black Mesa, there is potential for Cambrian tapetes and Bright Angel to provide reservoirs. As you see here in this next slide, that the neighborhood has been proven to be very productive. In the San Juan, 60 trillion cubic feet equivalent estimated ultimate recovery was discovered from 90% from the Cretaceous strata, CBM, and sandstone. Paradox, 1 billion barrels of oil. Estimated ultimate recovery, 0.5 potential. Black Mesa, yet to find. The Black Mesa is representative of a true pre-seismic basin. Drilling has been sparse and has historically been directed to surface anticlines. The basin is surrounded by several prolific fields, including tar sand triangle and circle cliffs, each having produced over 10 billion barrels of oil estimated. Due to the large area and rugged terrain in the Black Mesa Basin, exploring solely with seismic data would be prohibitively expensive. But potential field data can be used effectively to identify target lead areas. This next slide demonstrates why the Black Mesa Basin is considered a frontier exploration area. There is sparse well control, all 1940s to 1970s vintage. In general, wells were positioned where roads intersected surface structures. In comparison with the well-bedded San Juan, very few wells have been drilled and geologic understanding is limited. Seismic information is also very sparse, and because of the rugged environment and large area, it would be expensive to acquire. In the Black Mesa, no seismic data is available, internal or commercial, other than a few single-fold short 1960s vintage. In the San Juan region, 2D seismic data is sparse. 3D is typically acquired for Cretaceous targets. In the basin, geophysics has used to narrow the focus to targeted areas. This provided a way of grading targets for reconnaissance 2D seismic acquisition. The aeromagnetic data that you see here is a subset of the public source GeoNet magnetic repository available through UTEP. The map was used to facilitate correlations to other geophysical and geological maps. The white line here is the location chosen for our 2D geophysics model. This residual gravity map, dated 2005, covers the entire area of interest. A 40-kilometer high-pass filter was applied to the data to isolate anomalies. The 2D structural model starts at the Kaibab uplift across both the Black Mesa and San Juan basins and terminating at the Nacimiento uplift. The sedimentary section shown with this slide was based on a geologic well-based cross-section across the Black Mesa. The basement was interpreted to be of granite and gneiss terrain. It was faulted to form 13 synrift grabens and half-grabens. These synrifts and half-grabens are estimated to each contain up to 5,000 feet of Proterozoic, Chuar, and Unkar groups in the San Juan Basin, and 2,000 feet of similar groups in the Black Mesa Basin area. The results of calculated gravity and magnetic fields due to the structure model match very closely with the observed magnetic and gravity data, providing higher confidence in the interpretation. Although the overlying Black Mesa sedimentary basin is broad and symmetric, with formations ranging from Paleozoic up through Upper Jurassic, the basement deep has an interpreted high block located at the center of the basin. The 2D models show the Proterozoic to be absent over the basement high, with the high essentially subdividing the deep Black Mesa Basin into two troughs. The San Juan area is similarly floored by non-magnetic Proterozoic horizon, underlain by the deeper basement structure derived from IGC's magnetic interpretation. The overlying San Juan sedimentary is asymmetric. Its western flank, formed by the Defiance uplift, is relatively gentle, and its eastern flank, formed by the Nacimiento uplift, is steep. A Paleozoic depot center is developed over the deep central basement, but the Cretaceous depot center is shifted eastward toward the Nacimiento uplift. The result of the multi-science approach elevated the exploration potential of the Black Mesa Basin to high risk due to the low yield expected from the potential Chuar-type source rocks. Through the use of geophysical data integrated with existing well control and surface geology, the need for a regional grid of 2D seismic data was downgraded, with a cost savings estimated at $6 million. If interested in additional information on the data, interpretation technique, and results used in this work, please contact Integrated Geophysics. A special thanks to Tom Bulling and BP North America Gas Group.